In this video, I'm going to be showing you how to use approximate matching. Now we've looked at the index match function, VLOOKUP and XLOOKUP, and in every case so far we've used exact matching, where we exactly find the value that we're looking for. There are cases though where you want to find an approximate match, so you want to find the closest value to what it is you're looking for. So for example, I might be interested in knowing which student has the highest score less than or equal to 80%. Right, I don't know that a student's going to have exactly 80%, so there might be a student that has 79 or 78, and I want to find the student that is closest to that 80% threshold. So to do that, we can use approximate matching. So I'm going to set up my formula here. We're going to do an index match. So index, what I want to get back is the student's last name. That'll help me to identify the student. Now I'm going to use the match, and my lookup value is going to be that 80%. Again, I don't know that 80% is going to be in the data. It might be, and it might give me an exact match. But if it's not, it's going to give me the next closest thing. And in this case, we're going to be doing the next closest thing that is less than or equal to 80%. So that's a really important distinction. We'll talk about that in just a second. I will select my lookup array the same as I would normally. And now, where this is different than exact matching, right? Exact matching, we put a 0 in here. Now we actually want to use approximate matching, and so we're going to say less than, right? Because we want to find the highest score less than or equal to 80%. So in this case, we're going to close off our parentheses, and let's see what our answer is. Our answer in this case is Jones, which is associated with 78%. And if we look at our data, we see it's actually organized in ascending order. Ascending meaning it's getting bigger as we go down the data. And we see that the first one bigger than 80%, well, that's 82, so that's not our answer. So it is Tim Jones with a 78% is the highest score, less than or equal to 80%. So very importantly, when we use this index match, and the match is set up to find the next value, again, less than or equal to our threshold, and let's see that. So we see our match type is 1 for less than. In that case, we have to make sure that the data is organized in ascending fashion, right? Like it is right here, it goes from low up to high. If that's not the case, this function is not going to work properly. And let me show you what I mean. So what I'm going to do is just highlight all this data. A shortcut I use a lot is Alt-DS. That's Alt Data Sort. And in this case, I'm going to sort this data. It was sorted smallest to largest. That would be ascending in this case. Let's flip it to largest to smallest. When I flip it to largest to smallest, now 98% is the first score, and my formula now gives me an NA, a not applicable error. And what is happening here is, we can understand what's happening here if we understand a little bit more exactly how the function works. So let me actually redo for 1 second. Let me undo that sort, and let's look at it in ascending order. And notice up here I say it finds the first bigger value and then it goes back by 1. So here we kind of got to think like the computer. I'm looking for 80%. I start in the first cell and I say, is 67% bigger than 80? No, let's go on. Is 74 bigger than 80? Nope. 78, is that bigger than 80? No. 82, now that's finally the first value that's bigger than 80. As a result, it then goes back by 1, and it says, Tim Jones is my answer in this case. The index will give back the Jones, right? So that's how it's working if the data is organized properly. If instead we sort it and we flip it largest to smallest, so now it's descending data, now we can think about what the computer does. It starts out and it says, all right, let me find the first thing bigger than 80%. Oh, look, 98%, that's bigger than 80%. Let me go back by 1. Well, I was in the first cell, so I can't really go back by 1. Thus, the NA error. So we can see what this looks like if we throw in 99%. All right, that will change our threshold now. Now we get the answer of Gentry. So in this case, it goes down the whole list. It never finds anything bigger than 99. As a result, you get the last item in the list, which is Gentry. Again, because it's expecting the data to be organized from smallest to largest, since it never got to the largest value, it gives you the last thing in the data, which clearly is not correct in this case. The highest score, less than or equal to 99%, is Pierre Cox up here at the top. So we only get the correct behavior from the index match with the less than matching, which is the 1, as long as the data is organized in an ascending fashion.